There are three cases, okay, in which our sets, which will require the use of Z and T, okay. And the first case, case one, is where your population variance or population standard deviation is given, okay. So population variance is given or is known, good. If it is given, you use the Z, okay. And the Z, like you can see the formula over there, is just your observed mean minus what? The null mean. We saw that in class. So the observed mean from your sample is X bar minus what? The null mean, which is the population mean, the claim mean, over the standard deviation, okay, divided by the square root of n. We saw this. This is just a standardization formula for the sampling mean, okay? Good. So that will be as a statistic. Now, in the case of in the case where your population variance is not being provided, you don't know it, it's not given. When it is not given, then we also say it is unknown. So once it's not given, you don't know it. And let me highlight, we are saying population mean, not sample mean. So if the population mean is not given, we know that we can also find sample mean, okay, as an estimator for the population mean, right? Or as an estimate for the population variance. We saw that in class last week, right? We said that the estimator of the population variance is a sample variance, which is S squared, right? Good. So in the case where the population variance is not given, you have to first find the sample variance, okay? Good, which will be what? Sample variance will be S squared, okay? But we need to ask ourselves two questions to determine whether to use Z or to use T, okay? The first question is whether the sample size, because you are using the sample to find your S. Now, if the sample size is greater than 25, let's use 25, okay? So if the sample size is greater than 25, then you will still make use of what? Your Z, okay? You still use the Z statistic, which will still be Z is equal to what? Is equal to X bar, okay, minus the mu over this time, because you don't have sigma squared for you to find sigma, you rather use the sample standard deviation, which will be S, the square root of the sample variance over square root of n. So when the population variance is not known, use the sample variance, okay? And then replace the population standard deviation in the formula with the sample standard deviation. But you need to ask yourself, if the sample size is large, that is bigger than 25, then you use a set. But if the sample size is smaller than 25, okay, if it's smaller than 25, then use the T statistic, okay? So we call it the student T statistic with n minus 1 what? Alpha n minus 1 degrees of freedom, okay? Good. And then it is the same formula. The difference there is the reading of the tables. We'll go and read the critical values from the T table, not from the Z table we used last week. So it will be the same formula in both case of small sample or large sample. But for small sample, we will read the critical values on the student T distribution table, okay? While for large samples, we'll be using the sets, right? And there is a theory behind that, okay? Good. Now, let's continue. Sorry. Okay. Yeah. Now, another thing we need to understand is depending on
types of test and rejection region table 10.3 types of tests.
So depending on the sign of your alternate hypothesis, okay, which is your HA, in this case written as H1, depending on the sign, we can determine whether the rejection, which is your alpha, will be on the left, will be on the right, or will be two-tailed, okay? So as we move on, we'll look at that demonstration for you to understand why when it is less than, when mu is less than some value is left, but when it's greater than is on the right, and then when it's equal to is two-tailed. We'll demonstrate all that. So let's take our first example. The first example says what? A random sample of 1,000 iron rods recorded showed that the average length is what? That the average length is what? 71.8 centimeters. Okay, good. So we are dealing with sample. You need to read the question carefully. So a random sample of 1,000 iron rods, okay, showed an average length of what? 71.8. So our sample mean, okay, sample mean is what? The 71.8 centimeters. That is not a claim. That's a sample mean. Good. Then it says, assuming that the population standard deviation. So now we've been given the population standard deviation. So which means we know the population variance. It's just the square of this population standard deviation. So we've been given sigma to be equal to what? 8.9. So population variance can also be found, is known. Then we are asked that, does this seem to indicate that the mean length of iron rods is greater than what? So what is the claim? The claim we want to test is whether the mean length of iron rods exceeds or greater than 70 centimeters. Okay, so that is the investigation we want to conduct, because we are being asked, does this seem to indicate that the mean length of the rods is greater than what? 70 centimeters. Okay, good. That is what we want to test. Now, like we said, the first step is to state your claim. So in the statement of your claim to, what you do is you write the statement in a mathematical form. Okay, now you are being asked that is it true that the mean is greater than 70 centimeters? Okay, that is a claim. Then you write the opposite of this claim. That will be mean is not greater than. Not greater than means it's either less than or equal to what? 70 centimeters. Okay, when it's equal to is not greater than it. So these are the two statements you can have. Then the step three is to what? Check which one has the equal to, and that will be the statement. Okay, so we assign that to the null hypothesis. So you can see that in our null hypothesis, we have what? Mu is less than or equal to 70 centimeters. Whereas in the alternate hypothesis, we have mu is greater than 70 centimeters. Okay, good. So you realize that this will be the outcome for our null and alternate hypothesis. Now, what next? In step 2, we said you select your significance level, okay? And then fortunately for us, in the question we've been told to use what? Alpha. This is not A, this is alpha of 0.05. So you write it neatly, which is step 2 here. We write that is alpha is 0.05. Please give me a minute. The next step is to decide on which statistical, okay, or which statistics we are going to use.